All right, so we've got some problems in lesson 76 to go over. So we know that A crosses the x-axis. So A is going to be x is equal to, and it's crossing the positive 5, so x is equal to 5. Because x is a straight line, x is always going to be 5, because no matter how far you go up or down, x is always the value of 5, and y can be any number. So for B, we want to look and see what we have. We want to see, first of all, that it's a slope, so we know it's going to follow y is equal to mx plus b somehow. So first of all, let's find our slope. So we've got a point in the middle here, and we got another point here. So we're going down 1, so that's down 1, and then to the right 1. And because it's down, that makes it negative. So we have y is equal to negative 1 over 1x, and it's crossing the y-axis in the center at the 0, so plus 0. So if we simplify this, y is equal to negative 1 over 1 is negative 1x, and this plus 0, it's not changing this value, so we can drop it. So it just goes away. So we can leave it as y is equal to negative 1x, or we can remember that the 1 is invisible, so it's really just y is equal to negative x. Now you can check that. Anytime you write the equation of a line, you can always find a few points and check your answer. So let's pick up this point on the line, let's pick this point on the line, and let's pick another point down here. All right. So here I've got negative 4, 4. Here I have negative 2, 2. And here I have 4, negative 4. So my x values are negative 4, negative 2, and positive 4. So I'm going to say x, I'm just going to do the table that we used to do in pre-algebra. And y is equal to negative x, whatever we put in for x. So negative 4, negative 2, positive 4, negative 4, negative 2, positive 4. So negative 4 is a positive 4. Negative 2 is a positive 2. And a negative positive 4 is a negative 4. So our points should be negative 4, 4, negative 2, 2, and positive 4, negative 4. Negative 4, 4, negative 2, 2, and 4, negative 4. So those all check out, which means that we did this correctly. So you can always put this equation back into the table we learned in pre-algebra to make sure that your equation of the line is correct. So sometimes you might want to do that if it doesn't look right. Like this is not a typical format for us. We usually have more things there, right? So you can always check it that way just to make sure that you did find the right solution. All right, let's look at the next one. Here we want to factor the binomial. So the first thing that I see is that both of these constants or coefficients here in front of the variable, they're both even numbers. So that means I can take 2 out and reduce this to negative 36k squared plus x squared. I also notice that because this is a negative, and when I look at it now, I see that this is a perfect square and that this is actually the number 1, but it's a perfect square, and then x squared is a perfect square. So if I rearrange it and put the negative number second, now it is in the format of a perfect square. We have the minus sign in the middle, and both of these can be found easily. So we would say x plus the square root of 36 is 6, and that'd be k, and then x minus 6k. And that would be our solution. Sometimes you have to take or reduce the values here to get to a perfect square that we know how to factor. So think about that when you go into factoring it. And whenever you see this negative number in the front, see if you can reduce this and rearrange it so that it looks like a perfect square. And it's very helpful to know your squares, to have them memorized. 1 times 1, 2 times 2, 4 times 4, 3 times 3, 5 times 5, 6 times 6. If you know those multiplication tables, it's easier to see this before you get started. Let's look at the next one. Okay, so this one says use substitution or elimination to solve. So that means you get to choose which one you want to do. So I'm looking at this problem though, and I see that we've got a positive 2y and a negative 2y. So I think elimination is already set up for us. So I can just draw a line and I can cancel right away. So then I get 5x is equal to 14 minus 4 is going to be 10. So if I divide both sides by 5, x is equal to 2. So that's my first point. 2 is my x value. Now I need my y value. And you can get your y value just by substituting in for x. So I'm going to do the top one just because it's smaller numbers, which means that it is going to be easier to solve. So 2x, that's going to be 2 times 2 plus 2y is equal to 14. So 2 plus 2, or 2 times 2 is 4, plus 2y is equal to 14. Subtracting 4 from both sides so that I can get y by itself gives me 2y is equal to 10. So if I divide both sides by 2, y is equal to 5. So that would be my point. This would be the answer that we're looking for. All right, let's see if there's another problem. Okay, so here's another one. We're going to add writing the numerator terms in the top blanks with their signs and the denominator in the bottom blank with their signs. So first of all, we need to find a common denominator in order to get these all to have the same values across the bottom so we can combine the values across the top. All right, we got to have a common denominator to do that. And it looks like the most number of times x is used is 3. And it looks like the most number of times that a is used is 2. So a2x3, that's going to be our common denominator. So we're going to multiply by whatever's missing in the denominator. So in this first term, we have an x squared. So what we're missing is a squared and 1x. So a squared x over a squared x times that first one. All right, looking at the second one, we have a and x squared. So it's missing 1a and it's missing 1x. So ax over ax times 2 over ax squared. Plus, now we look at this next one. We have the x cubed, but we're missing the a squared. So we multiply by a squared over a squared times b over x cubed minus, look at this last term, we have the a squared, but we don't have the x cubed. So we multiply by x cubed over x cubed times 1 over a squared. Now they should all have the same terms across the bottom. So we would multiply. We'll do our multiplication now. So a squared times a is going to be a cubed x on top, but then we get a squared x cubed on the bottom. So that matches. Plus, now we have 2ax on the top, but we have a times a is a squared, and x times x squared is x cubed. So that matches this one. So it's common denominator. Now a squared times b will be a squared b on the top, and a squared times x cubed is a squared x cubed. So these all match so far. Now we've got x cubed times 1, so that would just be x cubed, over x cubed times a squared. We put that in alphabetical order. Now we have a common denominator. Everything matches. So that means we can combine the values on the top. So what we would do in the top is just write these values. So we would have a blank in the top that says a cubed x. Then we would put in plus 2ax. Then we would put in plus a squared b. And then we would put in minus x cubed. And then the bottom, the numerator, would be a squared x cubed. And that should be your final answer. Each one of those terms in the top, you put in by itself in a blank, and then the one in the bottom, you put in the numerator, you put in the denominator blank. So this is a blank, this is a blank, this is a blank, and this is a blank. And then this is a blank. And that's what it should look like in your Jupyter, that each one of those are put in separately. All right, I think there's one more problem. All right, here's the last one in lesson 76 that we needed to work on. It says to simplify, and we have some radicals here that we need to factor. So 3, I'm going to factor this radical. 20 is 4 times 5, and the reason I said 4 times 5 instead of 2 times 10 is because I know 4 is a perfect square, so I picked that one to use because I know I can factor out this and make it a 2. So then 3 times 2, that would be 6 times the square root of 5. Now I want to go to this one. I'm going to do the same thing. I'm going to look for a perfect square. So 2 times, and if I look very carefully, I see that I could say 8 times 10, but I could also say 16 times 5. Well, 16 is 4 times 4, so I can pull out the 4. So that becomes minus 8, because 2 times 4 is 8, times the square root of 5, because that's what's left over on the inside, plus 2, and here I've got 25 times 5, so I know that is a 5, so that would be plus 10, and I have a square root of 5 remaining, minus, I see the square root of 5 times 100, and we know 100 is going to be 10 times 10. This is actually a 1 right in front of there. It's just invisible, right? Whenever we treat the radical like a variable in that there's an invisible 1 in front of it all the time if there's not a number here. So 1 times 10, negative 1 times 10 is a negative 10 times the square root of 5, which is the thing that is left behind. So now, because all of these bases match, all these radicals match, we can combine these values. And when I look, I see that we have a positive 10 and a negative 10. So they're opposites. So we know when we add opposites, they cancel each other out. So we can just ignore that one. And I have a 6 times the square root of 5 minus 8 times the square root of 5. So that is 6 minus 8, which would be a negative 2 times the square root of 5. And that would be your final answer. Okay? All right, that is the last problem. If you have any other questions, continue to message me and I will get to them as soon as I can.